Okay, welcome everybody to the first monthly, hopefully, Akka.net virtual meetup. We have a huge crowd here, which is super exciting. We've got something like 100 or 150 people RSVP'd, so thank you guys, everybody around the world for making time in your day to be here with us. My name is Andrew Scottsko. I'm the co-founder of Petabridge. I probably sent you all a lot of emails, so, sorry, but hi. Yeah, so we're going to just dive right in here. We've got a great lineup. Roger, I'm going to hand it off to Roger here in a second. And then we have two awesome speakers, Aaron Standard and Joshua Benjamin, who are going to be sharing their stories about with Akka.net and teaching you guys a lot about what it can do for you. So without any further ado, I want to hand it off to Senor Roger Alsing, founder of the project itself. So Roger, welcome, man. Take it away.
Thanks. Well, hi, my name is Roger, and I started Akka.net before it really was Akka.net. As a hobby project, mostly to learn the actor model. And I started to play around with it and started to, just for fun, port the Scala Akka. And about 2 months later, Aaron contacted me and said, I want to use this in production. And then it sort of took off. So my main focus on Akka.net is the core module, the Akka actors, and the configuration, the Hokan parser, and serialization, and to some extent the remoting library, the remote deployment. I do consulting on Akka.net and consulting in general, so that's what I do. And over to Josh.
Hi, I'm Joshua Benjamin. I'm a software engineer, and I work in the public transit space. And I got a little presentation. Can you guys see that okay?
Yep, looks good, Josh. Just go put it in presentation mode.
Okay. I might, let's see. I don't think it's sharing the presentation mode. Hold on. Try something again. Share my entire screen for now.
All right. Oh yeah, and just while Josh was getting that ready, so we have the ability for you to type in questions that'll show up in our moderation queue. And what we're going to do is Josh is going to give his presentation, and we're going to take some questions related to that. Then I'm going to do one. We'll do some QA around that, and then we're going to have open microphone at the end to address totally open-ended questions from any Akka.net user or contributor, or anyone who has any questions. So we'll deal with the sort of open-ended questions at the very end. But without any further ado, we'll go ahead and have Josh talk about how he uses Akka.net in production at Synchromatics. So take it away, Josh.
Okay. Can you see that all right?
Yep, looks good.
Okay, awesome. So a little bit about who I am. My name is Joshua Benjamin. I'm a software engineer, and I work at Synchromatics. What we do is we provide real-time and historical analytics on public transit. So we track public buses and get data out of that, such as stop times, are they adhering to their schedules, where they were, a lot of cool stuff. Let's see. So we are a .NET shop. We use SQL Server, Akka.net, but we also use a lot of open source software such as RabbitMQ, Hibernate, Elasticsearch. So we're not your typical .NET shop. We try to use the right tool for the job, and that's how we found Akka. So with our legacy system, you'll see this a lot. We had some problems. High availability, there was none. basically what we had is our Windows services running on different machines, and we'd have a customer per server. So you could think about the city of LA, their buses would all be on one server. And if that server goes down, the entire system for LA would go down. So that was definitely not desirable. Another problem we had is concurrency. So dealing with the messages from the vehicles, we have to process them in order to figure out what the vehicle is doing. Is it on route? Is it on schedule? And with those types of systems, you have to deal with locks and messaging, a whole bunch of other stuff other than the problem you actually want to work on. Testability, our code was in large classes, very untestable, and readability was a big issue because of those large classes. Yep. Let's see. So our Akka.NET solution, we started looking around at the actor model because of these problems we were having, and it's a perfect fit for what we do. So high availability. Akka has this concept of routers, and we found that the consistent hashing router would allow us to send all the messages for a particular vehicle all to the same server, which is good. And it also supports failover. So if I have a cluster go down or a node go down, it would reroute it to a new one. Let's see. Concurrency. Actors are inherently thread safe. We don't worry about locks. So our code is not riddled with lock this resource and make sure nobody else is using it. It's very clean and deals with the problem instead of fighting the framework. It helped with testability. Our actors are small, have only one job, and they communicate with each other via messages. So messages in, messages out, it's very easy to test what they do and what they're supposed to produce. Let's see. It helped with maintainability. Our actors are small, easy to understand. It took 85% less code to do the same job because we don't have to deal with locking and those sorts of things. Excuse me. Let's see, the code is just focused on the problem. And I have a little diagram here that shows we're not all the way here yet, but we're getting close. So all the vehicles talk via UDP. And what we have here with the gateways is Akka.NET nodes that are listening for those UDP packets. And there's a load balancer over the top of that. Now, the gateway takes in the message and then puts it out via a consistent hashing router. And we have our vehicle hosts there that receive those messages and process them in order. So if we had one of these servers go down, the other servers would take that load. And we still get the concurrency of only dealing with one message at a time per vehicle.
So hey Josh, this is Aaron. I wanted to ask some questions for clarification real quick.
Okay, go ahead.
With the way you had your system before, was you had sharded your data essentially where it was grouped all by customer per server, right?
Exactly, yeah.
So if a server went down, that entire customer's system went out.
Absolutely, yeah.
Whereas the way you have your system now, you're basically able to go and shard the data by vehicle, and if one of those servers goes down, you're able to go and move that data to a new server now, right?
Yeah, and we don't even move it ourselves. Akka just sends the messages to that new server, and it just gets processed.
Mm-hmm.
So our affinity is a lot better. It's the affinity down to the vehicle level versus the customer level.
Yeah, makes sense. So in terms of all that, so you mentioned on the previous slide you were able to eliminate 85% of your code by rewriting this using Akka.NET Actors. So before, you weren't able to have this availability that you have now by being able to shard data using the consistent hash router, and I assume you're using Akka.cluster for this, right?
Yes, we are.
Yeah. And so with all that code you were able to eliminate, what was that stuff doing? Was that mostly like shared state concurrent programming code, or did you have like your do-it-yourself network infrastructure there too? Tell us a little bit about that.
Oh, a lot of it. There's a lot of shared state, a lot of networking, messaging code. So dealing with UDP, TCP, and then taking those messages, putting them in a queue, and dishing them out to our workers to process it. Yeah. So there's a lot of code around that. A lot of code around just ensuring that the messages per vehicle were processed in order.
Mm-hmm. And the actors were able to basically take care of all of that stuff for you.
Yeah, it's and what we're left with is just worrying about the problem.
Gotcha. And one question that I know we get asked this in the Gitter chat a fair bit was, you were the engineer who sort of led this re-architecture at work, and you've got a team of at least half a dozen people that you work with. How easy was it to train the other people you work with on this actor-based approach to doing it?
Oh, it was relatively easy. Once everybody understood what an actor is and the communications between actors, it just clicked.
Mm-hmm. And it's probably a lot easier to get them to click on a code base that's 15% the size of the previous one too, right?
Absolutely. It's easier to distribute the work and read other people's code when you do it. What we did was we were able to take a problem like when does a vehicle stop at a stop and break it down into individual actors that worked on part of that flow. And then we were all able to get in and work on those individual actors and then piece them together.
Mm-hmm. Got it.
Did you have any sort of pitfalls when introducing Akka, where you sort of applied the actor model maybe not optimal at the start?
We have a little bit where we're still we have dependency injection, so working with that and Akka, there's a little bit of that, a little bit of cluster issues, which weren't necessarily pitfalls in working with it. I would say the biggest one is dependency injection and working with that kind of stuff.
Yeah.
So DI initially was an issue then.
Yep. And we still have DI, but it's becoming clear that the actor system itself with different actors are your DI. So if you wanted to get something from a database, you could have an actor specifically doing that job. And then you're asking that actor, hey, I need this from the database.
Mm-hmm.
Versus injecting a repository or something like that.
So you just send a message to an actor that talks to your database and get a message back rather than injecting a repository.
Exactly.
Cool, got it. And since you've had this in production presumably for months now, how did you monitor and manage this in production?
Oh, okay. Yeah, it's been in production, I want to say about 3 months, maybe longer. So we use StatsD, Graphite, and Grafana to monitor. Really, really easy to set up. I have some scripts for Vagrant if you guys want to try it out yourself. let's see, we deploy it using Ansible. So we can deploy bits and pieces of it we just tell our chatbot to deploy, so it's really easy. I can show you what the monitoring looks like. So with Grafana, we can get graphs and make them. And it's really hard with a back-end system to sort of visualize what's going on. So what we have is our messages per minute in here. We have timings of our messages, and we're able to see the messages flowing through the system.
So you used, did you use the Akka monitoring plugin that's on NuGet for this?
Yes, definitely did that.
Sorry, shameless plug. I wrote that.
Oh yeah.
So yeah, tell us a little bit about what are the sorts of things you monitor and like which metric. How did you pick which metrics to pay attention to?
It depends on the actor. The main metrics are received, so the amount of messages received. That helps us ensure that messages are flowing through the model, flowing through the system. I would say that's the biggest thing to track. We also got into tracking timing, so how long is an actor taking to, process a message? And then we have some custom metrics in here to ensure that what's the state of the actor and how does that change.
Gotcha, makes sense. So for the deployment side of things, so you mentioned you use Ansible to go and do scripted deployments. I can see on the slide here, it looks like you're planning on using Docker and Ubuntu.
Yep.
At some point in the future. Could you tell us a little bit about what were some of the things that you had, what might have, if anything, what was different about how you deployed Akka.NET based like Windows services versus whatever you had before? And what are some of the things you had to learn how to do in order to deploy it? What can you share about that?
I think there wasn't much difference as far as our other application. There are Windows services with top shelf, so we basically had a role in Ansible for deploying those, and we just reused that. I definitely would say that in Akka cluster, using the seed nodes and what you call lighthouse is definitely important. Like, we had it where we didn't have those before, and we only had one seed node. So every time we deployed, we'd have a new cluster, and when we deploy that one machine, we'd have to redeploy everything. But with the seed nodes, we don't change those. They stay there, and we deploy everything around it.
So that simplified like the ability to actually go and form a system where all the nodes were aware of each other.
Yeah, absolutely. And in the future, right now we're replacing our nodes, but with the seed node concept, you can basically add nodes, and then the cluster the router will rebalance and start putting traffic to those nodes, and you can see their error rates and how they're performing, and then you can take the other nodes out of the system. So you can almost do a blue-green deployment in a single cluster.
Yeah, makes sense. And one thing I didn't see mentioned on the slide that I thought I'd ask about is where are you deploying this stuff currently? Are you on the cloud somewhere in your own data center?
Currently, we're in our own data center.
Okay, gotcha. And was there anything about that made this easy or difficult? We have a lot of folks who, for a lot of the people who are looking at using Akka.NET work in industries like finance and healthcare, where they're, for a lot of regulatory reasons, had to be a little sensitive about what they can and can't run on the cloud. So we have a lot of people using on-premise. So is there anything you can share there that would be helpful for them?
I would say script your deployments, use Ansible, use Chef, use something like that, because it really simplifies deploying to machines, and if you want to take the cloud approach or the on-premise approach, you basically just change to where those scripts point to. Yeah.
Gotcha. Makes sense. So we've got some questions from the audience, unless you have... oh, there we go. Perfect. So we have some questions from the audience that we can dive into. Do you want to answer some of those?
Sounds good.
All right. So top question right now. Oh, hey, you're running... didn't realize you were running Ubuntu for this today. That's awesome.
Oh, yeah.
So the top question right now is, can you provide a link for the slides?
Yeah, I'll be posting those up on the Hangout.
Cool. All right, so yeah, we'll have those up there. Next question is from Arjun Smits, which is, did you guys use Akka persistence for your storage interface, or do you use something else?
We don't use persistence yet. We're definitely thinking about using it. We have our currently don't have persistence, but we would like to save the state of those actors. So if we had a machine go down,
Yeah. So today you kind of have to hand roll your own system to go and recover that state, right?
Yeah, it's in basically what we're doing right now. There's not much state to recover. We're saving as we go, and
Yep. So just basically go and rehydrate it when the actor starts.
Exactly. Yeah.
Yeah, that's exactly how I did it in the story I'm going to share next too. Next question. So we have a DI question. So are you using dependency injection to resolve your actors or their dependencies? What approaches have worked well for you? If not, what other methods do you use to isolate dependencies for testing? That's from Gen F.
Yeah, right now we use dependency injection to resolve our actor and all their dependencies. We have a little shim, excuse me, in Akka to do that a different way than what's out there currently. Let's see.
Yeah. So what other methods you use for isolating dependencies for testing?
I would say the actors themselves are the best way to isolate dependencies. We're starting to move more to, if we need to get to the database, we have an actor for that, and those sorts of things.
So you have like a utility actor that wraps a repository for a database, and you can mock that really easily with other actors.
Exactly. And then if you have something like that, you don't need dependency injection for that.
Yep. You can just use, like we talk about, like the reply to sender pattern as a really easy way to make your actors testable, where you can go ahead and just send a message from like a test actor or something, and then perform assertions on that, right? Cool. And then, Josh, I don't know if you've got an answer to this question, because I don't know if you use Akka.net and ASP.net at all. But there's a question on, are there any pitfalls with using Akka.net with ASP.net MVC?
We use Nancy, but there isn't any pitfalls really. We have our Nancy nodes ask actors out of our cluster things like how long is the vehicle going to take to get to the stop, and it's been pretty easy to do that. I haven't seen any real pitfalls.
One follow-up question on that, Josh, because I saw some, I got some questions in email the other day that I didn't know the answer to, specifically regarding using Akka with Nancy. Has there been anything in that process of developing the application and integrating the two that you wish you had known when you started?
I'd probably, I think. Ensuring whatever you're hosting it with, if you're hosting it with IIS likes to take down an application if it's not in use. So if your Nancy or your web node is actually part of the cluster, it'll be, you have to watch that because it'll take it down if it's not in use and stuff like that. But as far as communication with the controllers to the actors, no, we haven't had issues.
Yeah, to follow up on that, one pitfall that I warn people about with ASP.NET or Nancy in combination with Akka.NET is if you're using IIS and you have app pool recycling turned on, make sure those actors that are running inside your web application either have some way of backing up their state to a durable store, or even better, make it so they don't have any state. So make it so they push their information to a stateful service running in a Windows service somewhere else. Because those application pool recycles essentially reboot the entire process from scratch.
Yep.
So yeah. So I guess follow-up question from Philip is, do you self-hosted, Nancy, or do you run under IIS for that?
IIS right now. We want to move it to self-hosting on a Ubuntu server, but right now it's IIS.
Got it. And we got a question from Natan. How do you switch actors for testing without DI?
Switch actors for testing. Not sure.
So I guess like mock an act. So if you have normally if you have these two actors talking to each other in production, how do you go and replace this one with something testable?
Okay. Basically, your actor is your unit of work. So you put in messages and you expect messages out, and that's really the way we do it. We just put in messages, and we expect certain messages out. So we don't have to switch other actors. And if it needs to talk to another actor, you basically can listen for a message, and yeah. I don't know if that fully answers that question, but
yeah, it's one of those things where it's I know what you're talking about, Josh, where it's actually like trivially easy once you see how to do it, where you can just go and if your actor's job is just to send it receives one type of message back and sends something back to the sender, it's really easy to replace the sender who sent that initial message with some other type of actor. So like in the Akka.NET test kit, we have the test actor, which has a collection of messages you can inspect and make assertions on. So you can expect like the message at the front of this queue should be of this type and should contain this data. And so you can use that to really easily mock actors that look and feel as though they're the same one that you would normally have in production, but actually aren't.
Yeah.
Yeah. And you don't need a mocking framework or anything to do that. It's just as easy as just replying to the sender. And because the actor references are transparent, you don't necessarily know what the implementation class of the actor is who sent that message.
Exactly, yeah.
Yeah. Cool. Let's see. There's a couple of questions here that are more general about Akka.NET, so we'll answer those towards the end today. But do we have any questions specifically for Josh still? We'll go ahead and give him a moment to type in there.
Yeah, we got a couple minutes left before we got to switch to our next talk. So get them in now, people.
But those were really great questions, though.
Yeah,
and Josh, you did a great job answering them, so thanks.
Thank you.
Yeah. And Josh is going to be sticking around to answer questions at the end too. So if you haven't thought of it yet, you'll have a chance to come up with them during my talk. So, all right. Well, speaking of which, I'll go ahead and get my show on the road here.
Yeah, I'm not seeing any new questions coming in, so let's go ahead and we're going to transition over to Aaron's talk now.
Alrighty.
All right.
Go ahead.
Great job, Josh. Thanks for leading us off, man. That was great.
Thank you, guys.
Right at the last minute, someone snuck in a question.
Okay.
You can go ahead and answer that while I'm getting my slideshow up.
Yeah, so follow-up question from Gen F is a follow-up on our DI question. Who creates the database actor that talks to the database? Does it have a supervisor, or is it a top-level actor? Thoughts on that?
Right now it's top level. Eventually, what you'd want to do is put it behind a router. So if you're talking to a database, you want a router that's a pooled router and can handle multiple. How do I put this? Yeah.
Can handle multiple messages going through it?
Exactly, yeah.
Sure. So that's a great answer. So Josh, this is a good question for you. Where did it go? I lost it there. So there was a question we got from Anton. In your opinion, Josh, since you came to Akka without really, as far as I know, you didn't have any background in it. What are your thoughts on how long it takes to learn the framework from scratch, and any sort of critical things to focus on early for someone who's new to it?
I'd say maybe about a month, if that. I think one of the issues I had was the ask pattern, and also understanding that I can pass a message around with a reference to an actor, and then use that reference to route the message back later. So you can pass a message around to multiple actors before, and use that IREF to get back to the sender eventually.
Yeah, kind of like the idea that the sender of the message and whoever ends up responding, it doesn't necessarily have to be one-to-one. There can be other steps in between.
Yep, exactly.
Yep. Okay, awesome.
Oh, I have to say one more thing. We're hiring, and I'll post that email address up there.
Perfect. Perfect. Yeah. And on that note, by the way, if anybody in the audience is looking for work and using Akka.net, we've started basically. Aaron and I get a lot of emails from companies looking to hire people. So feel free to email us, and we will try to put you in touch with people who are looking to hire. So yeah, there are people looking out there looking to hire people. Developers for Akka. So if you want to do that, you're looking for a gig, let us know, and we'll do whatever we can to help out. Awesome. Well, we've got a couple more. I saw some general questions that we're going to address at the end. Alan, we'll get to your question at the end because it's more general Q&A. But yeah, Josh, thanks, man. And at this point, I think we're going to switch over to Aaron. Are you ready to go, buddy?
Yes, sir. Can you see my slides?
Yep. Take it away.
Alrighty. Okay, so this is the talk I gave at .NET Fringe. So it was a conference that Glenn Block and a number of other .NET community members ran in Portland earlier this year. So I haven't really changed the talk since then, but it was a really important one, and ultimately describes sort of how I discovered that I needed the Akka.NET project and what it really made available for me individually as a developer. So title: The Future of Distributed Programming in .NET. So we are living in exciting times as .NET developers right now. One of the things that is really important that's happening with the .NET ecosystem is Microsoft is taking active steps to make sure that .NET is bigger than just Microsoft. So the rise of the Mono project and everything that Xamarin's done has been a really critically important piece of the story. It's not all that uncommon now to hear stories like Josh, where they want to be able to run their .NET infrastructure on Ubuntu and Docker. I talked to companies that are actually fairly large enterprises that all have a desire to go and do this. And there's basically a ecosystem that is starting to now build around .NET that is driven by more community than it is necessarily Microsoft's sales arm. And it's really focused on trying to provide tools to make the lives of .NET developers easier and to allow us to do new things. And this story is really about how I experienced that running a fairly large .NET application. So I'm going to talk a little bit about my previous startup, which was Marked Up. We were an analytics company that did real-time in-app analytics for Windows 8, Windows Phone, and eventually even Windows Desktop. We integrated into applications that were originally designed for Windows 3.1 at one point. And our analytics product was really successful. So 30 million was the number of distinct devices per month that we had. So we'd have 30 million different devices connect and transmit data at any given time. We had 500 megabytes of event data per second coming in through our load balancer. So these are all the pieces of data that we'd receive as HTTP requests. And we'd have to go and transform those and denormalize them and write them to our database. Speaking of which, 100 million was the number of transactions we committed to our Cassandra cluster every day. So that is not a number to sneer at. So we were recording a lot of data and performing a lot of writes and updates all the time. And 30 was the total number of servers that we ran this application on. So it was actually pretty lean. About half that number, about 15 of those servers, made up our sort of big data setup. So these were fairly beefy Cassandra and Hadoop and Solr servers that were powering all of it. And then we had about The other half of those servers were Windows servers that ran our applications. So we had a sort of a microservices architecture built on top of ASP.NET MVC. We also had SQL Server for some portions of our work, and we had a lot of sort of service and REST-based tools built into our infrastructure. So we had this great product that was really doing a good job in terms of bringing customers on board, giving them a good experience, and it was be able to handle really sizable workloads with a relatively small amount of hardware. But the business side of the picture was not so rosy. So Marked was a startup, and I raised capital for it, and we had 12 months of runway at this point in the story. This is like 2013. So runway, if you're not familiar with what the term means in business, is the amount of time you have before you go bankrupt. So that means we had 12 months of capital to continue paying our bills sitting in our bank account at the time the story began. 3, that was the total number of engineers working on this team. That includes me, a guy I had who was a very effective front-end engineer, and then we had a sort of ops and sysadmin person who was really good at being able to manage our SQL Server and Cassandra and Hadoop clusters, and wrote a lot of code for dealing with the data infrastructure. And 0 was the number of engineers with prior distributed systems experience before the story began. We had to learn everything we did on the fly. So the big problem that our product had was that despite the fact that it was useful and people loved it, analytics was a fairly commoditized business. You could use, if you didn't want to pay for our service, you could use Google Analytics and get a crappier experience for free. And there are a number of other ad-supported services out there like it. So we knew that in order for our company to survive, we had to really radically innovate. We had to come up with some way of being able to differentiate ourselves enough from those free solutions that people would open their wallets. So the idea we invented was this product called Marked In-App Marketing. And the way this worked was like this. It integrate our analytics SDK and this new client that we developed called the notification client. Users would install your app that had our SDK installed and would collect events, kind of like how we already had been for analytics. All that data would get pushed into our cloud, and our customers could create campaigns that could say, I want to send this type of message to users who've done events X, Y, and Z. So imagine if a user was taking a look at a buy screen inside your app and they decided not to buy something. A developer who installed our SDK could design on the fly in our marked up user interface a campaign that would send that person a discount code or something else. And this would be able to generate sort of additional revenue for a developer. It'd be able to allow them to do things like lure people back into the application who hadn't used it in a while and so forth. So this is a really attractive offering for the end users. So the last portion of this is that from Markedup's cloud, we'd go and push these notifications back towards end users. So the ultimate goal of this product was to really allow our customers to start conversations with specific types of users who would be able to generate business for them. And our customers loved this idea. We sort of tested some back-of-the-napkin sort of designs, and were able to go and validate that this is something our customers would pay for. But in our sort of user experience testing, we came across a very important discovery that would radically change the way we had to design this system, which was that we had the turnaround time between receiving those events that determined if an end user was qualified to receive a campaign or not, and then when they actually received the offer, that had to be done within seconds, because the difference for if the turnaround time was 30 seconds instead of 3 seconds, the conversion rate for our customers would be the difference between 40% and 4%. So it was an order of magnitude difference. So we knew that we had to be able to allow the system to react and send real-time offers in the order of seconds. So for implementation, we decided to start using the tools that we already understood and knew how to work with, which was HTTP plus a database. So all of us, we were experienced .NET developers. I'm ex-Microsoft, so I've worked with Microsoft tools for a long time. And we figured, well, the best place to start with this is just to use a web application and then use our database. And I ended up calling this technique read after write. Oh, it looks like PowerPoint just crashed, so I'm going to have to go and restart that real briefly. Sorry about that, guys. I was on such a roll, too. All right. Slideshow. Go ahead and begin from here. All right. Let me go ahead and restart my sharing real quick. Sorry about that. Okay. There we go. So we should have that back again. So we call this pattern read after write, which is we would go and write our data to the database and then read it back out to see if we had hit all the events that our customer needed in order to make sure that we were targeting the right people for this particular campaign. So here's our theory of how this would work. And if you're an experienced distributed systems user, the error I made in this theoretical model will be obvious to you, but it totally wasn't obvious to me at the time I designed this. So the way our setup was, we had our user. This was someone using one of our customers' apps. Then we had this HTTP load balancer. So this is running in Amazon's data center somewhere. So this is like an elastic load balancer. Then we had a bunch of our little front-end REST servers here that would receive data from the load balancer and from the end users that we were connected to. And then we had our Cassandra cluster underneath all this. So this was sort of our infrastructure setup. And imagine this user had to, we were going to go and qualify this user for a campaign based on events 0 through 3 arriving in our system. So once we had seen all 4 of those events, we could then go and qualify that user. So we imagine, user 0 would come in first, would go and write that to the cluster, would read back out that only 0 has been written so far, and so we wouldn't send the campaign yet. 1 would come into another server, would go and read from the cluster that 0 and 1 were back, and so forth. And we'd go ahead and continue going this way until eventually, on the last request here, we'd go ahead and read back that all 4 of the events have been written to our database, and then we can go and fire and send the message directly to the end user. And this would all work. So we actually set out and built this implementation, and we tried testing it internally. We actually hadn't intended on, we weren't even close to releasing this product yet, but we wanted to test and make sure that this worked. And here's what happened. So user, event 0 through 3, same infrastructure as before. So event 0 arrives. Then event 3 arrives. We haven't written 0 yet to the cluster, but event 3 is already here. So we go and write 0 to the database. Then we read back nothing. We don't have any consistent result yet. We go and write 3, and we get back some unpredictable, combination of 0, 0 and 3, or nothing. It could be any one of those. And then events 1 and 2 would arrive at the exact same time, and they would race to see who would get written to the database first and read back. So the truth was that no matter how many times we tried, even if we changed the consistency settings on Cassandra to use full consistency, which would make this application use substantially more resources than it would otherwise, it still didn't fix the problem. Even if we tried using SQL Server instead of Cassandra here, we still would have had this issue of the way in which the events were occurring across our cluster was never the same and was never predictable. Even if the SDK could order the events and wait for explicit acknowledgments to come back, which the first version of our SDK was designed to do, we changed that in the second version because that turned out to be really non-performant. But even under those circumstances, we could not make this work. And so I came to the inevitable conclusion that given the real-time requirement that we had, there was no possible way this configuration could ever work. No matter what I did to the database, and no matter what I did to the client or anything else in this picture. So I was stuck. I came to the painful realization that I had no idea how to build this product. And the thing that made this so painful for me personally was I didn't have the vocabulary to describe what was wrong. I knew that all the tools I knew how to use and everything I knew how to Google search for afforded me nothing. I didn't even know how to tell people what I ultimately needed to make my system work the way I wanted. So I got desperate. I roamed through the office whiteboarding stuff, continuously. Sometimes staying so late that I'd sleep on the couch. I think I got yelled at for doing that at one point because we worked in a shared office. But it was weeks of trying hard to really even figure out how to articulate what my problem really was and what I needed to fix it. But eventually I had a breakthrough. And my breakthrough was the realization that if we took this part of our infrastructure, and made it so all the events for this user ended up in the exact same place in our network, and all these events would arrive and be, would basically arrive in memory in one spot of our application. Then it became really easy to go and figure out if we should send this message back to the end user, and it became really quick to go and do that. So I realized this is what we needed. And then immediately after that, I realized that there's a word to describe this type of architecture. It's called a stateful architecture, where the application actually has state. We don't just hand it off to the database. We have the application actually be responsible for accumulating all the state and making decisions about it. It's in a more academic sense, that property is called state locality. And then immediately after I had this realization, I had this really painful one, that HTTP is a stateless protocol. So even if I tried to do stuff like make our load balancer sticky or something else like that, this ultimately wasn't going to work. There was some piece of my architecture that had to exist beyond HTTP, which is also where the name of Petabridge's blog comes from. And so then I had a second breakthrough, which was that this ultimately is a stream processing problem, that we would have a stream of events coming through our system, and we had to accumulate them into little state buckets to figure out if users were good fits for campaigns or not. And then we'd have to react to that state to go and actually send them a message. So I realized I had a stateful reactive stream processing problem. There's enough buzzwords in here to arrive on a very well SEO'd Akka landing page. And that's how I discovered the actor model. My story is no more elegant than that. I was able to go and Google for those terms, and I found out about Akka and the actor model. So great. So I found a technology and a design methodology that will help me solve my problem. I can use actors to accumulate state and then react to that state once it's satisfied this criteria that my customer can specify. So then, as a .NET developer here, I go ahead, whoops, man, I really need to improve the resolution on that image here. As a .NET developer, I had the following reasoning. I was like, okay, 1973 was the year the actor model was invented. For reference, 1971 was the year the relational database was invented. So this technology is pretty old. 1986 was the year that Erlang, sort of really made the actor model production ready. So that was the first real time it was available as something a developer could use. And this was like winter 2013, so like November timeframe, November, December, when I was doing my research here, and therefore I concluded, well, given that this technology was invented in the 70s and implemented in the mid 80s, and it's 2013 now, surely this must exist in .NET in some form already. Of course not. That'd just be too easy, right? .NET doesn't have nice things. At least it didn't back then. So I had to resort to contemplating the unthinkable. Porting everything to the JVM was the first thing that I tried. Well, I was like, okay, I really want to use Akka for this, but there's nothing even comparable to it at all in .NET today. So what would it cost to port everything to the JVM? So I spent 2 weeks learning how to use Eclipse and Maven and some of the build tools. I even rewrote some of our middleware that we used across our microservices in Java. And I ultimately realized that the lesser of two evils was simply to port Akka to .NET. And so that's where that's really where Akka.NET, as we know it today, started to become a real possibility. I had a problem I had to solve in production, and I needed to find a way to do it. So I originally started off on my own, implementing, trying to get basically Akka plus Akka.remote to work. And then eventually, after I took a little break around New Year's, I came back and found Roger's project, which was called Pigeon at the time. And I realized that the way he had implemented it was vastly superior to the way I'd been going about it. And I even ported his benchmark to compare. And around early February, teamed up with him to try to make it a real production usable framework for us. So 6 months later, after starting down this road, and so this would be by about May of 2014, we had Helios, the socket server that powers Akka.remote. That was the only thing I kept from my original actor implementation. We had that up and running. We had Akka.net plus the core bits and remoting were up and running. And then marked up in app marketing. We were able to ship the first version of it, including all of the SDK and other stuff. So me and my team were able to go and deliver all of that in the span of about 6 months. Now, ultimately, the story for Marked Up did not end happily. We ended up having to shut down the company in November of last year. Anyway, we simply didn't have enough time to really try to properly sell or market this technology in order to save the business. But the silver lining from that is I had the opportunity to start Petabridge with Andrew as a result of that. Akka.net got popular over the course of that time and became a framework that was a lot bigger than Roger or I ever imagined. And we realized that there was an opportunity for us to try to support all of the other users of Akka.net in solving these same types of painful problems. So what Akka.net really is it's a framework that creates new possibilities for developers. You know, the new reality of what we are expected to deal with today as individual developers is that data is trivially cheap to collect and store. Your users accept nothing less than excellence. There's a quote out there from Jason Calacanis, a famous entrepreneur, that users basically don't care about your app unless it's 5 stars, and that's, in my experience, is true. And so as a result of A and B on this list, there is C, which is that as developers, we're expected to deliver more. Arjun, one of the other contributors to Akka.net, described it as everyone is going to be expected to be a distributed systems developer in the next 5 years. And I think that's true. So some of the things that Akka.net allows us to do is really take a hard look at how things have been for us. So here are some things that I consider to be recipes for failure in this new future, where this reality is, where the reality is that we're expected to deliver more, and we're all going to have to build distributed systems. Applications should be stateless. That's simply not true. We couldn't build marked up in-app marketing without putting state in the application layer. And believe me, we tried empirically to prove that wrong at great cost. The next is that request response is the way network applications should behave. You're not going to have the type of application that could do anything faster than a web server if this is the only way you can work with a network. Pub sub and push and pull and all these other methodologies exist for a reason, and that's because there's a lot of different response models that we need to go and build responsive, fast systems. ACID. ACID is something that makes us feel warm and fuzzy about SQL Server and a number of other database technologies out there. But the truth is that can't be the only way we think about consistency and durability anymore. The reason why NoSQL has been so popular is that this constraint of how we think about how we store our data limits us to a certain set of trade-offs that we don't even know that we're making. So ACID can't be the only way of doing it. Just put a queue in front of it. I've thought for a large number of applications this was just a bad idea to begin with, but ultimately that's not enough to really build a distributed system. Is that you ultimately need to have something that's a little bit more clever than just a queue. Like Josh talked about in his talk, being able to use a consistent hash router to change targets for where you're accumulating data to is something that's not possible with just a queuing technology. There needs to be something that's a little bit more intelligent behind that. And finally, the biggest recipe for failure as .NET developers is that Microsoft will do this for me. The truth of the matter is that the .NET ecosystem as a whole is becoming a bigger place than just Microsoft. And if we limit ourselves to just the things that Microsoft can provide, then you're a development shop that can't use NoSQL, really. You're a shop that might not be able to, until very recently, take advantage of all the great deployment and configuration management technologies out there, like Ansible and now Docker. Docker's going to be included in the next version of Windows now, and that's great. It goes to show you that even Microsoft doesn't believe that their own in-house technology is enough anymore. So these are some of the assumptions that we should be challenging about our work as .NET developers. And some of the other things that Akka.net makes possible is that we have some new ways of looking at problems. Concurrency is our friend is one thing that we can do. So like Joshua found, being able to use actors to do things concurrently actually freed up a whole bunch of new eliminated a bunch of code you didn't need anymore, and made a lot of things possible. My application can be the single source of truth. There's a whole value in being able to have your application state be part of your application rather than be something that resides somewhere else. So this is a fundamentally different way of thinking about writing web applications than we've ever done before. Another idea is the concept of eventual consistency. This is why Cassandra is becoming so popular. Is it's one of the databases that's done a very good job of helping people touch this concept and make it more tangible and less abstract. The idea that consistency is something that's always going to be eventual anyway, even with ACID sitting in front of it. Reactive programming. We can write code that reacts to things rather than constantly polls for results. So think of it like that's like the difference between request response and pub sub, for instance. Pub sub is a very reactive way of working with messages on the network. Request response is a fairly it's a proactive way of programming, where your code is responsible for fetching its own dependencies. And lastly is location transparency. We can write code that has no idea where where it's talking to is on the network, and that's okay. And that's a really powerful idea. Like in the case study that we published this week, Joel mentions that he can one day take all the session state he has built into his Akka.NET application and just via configuration have all those actors deployed remotely on some central service somewhere. And that's something that he could do. So, what does this make possible for you is sort of the question that I want to end with here. If you had access to all this technology, what could you get? And that's what Akka.NET's all about. So I'll go ahead and end it there and take some questions.
Awesome, Aaron. Thanks for sharing that, man. So one of the questions that I see from Alan in the audience is he's asking about Akka remoting versus clustering. So Alan asks, are there situations for using Akka remoting independent of Akka clustering, or should it be treated as basic infrastructure used by clustering, but from an application point of view, you should use clustering instead and not remoting?
Gotcha. That's a fantastic question. So at the time, I used remoting just because clustering hadn't been written yet. That was why I used it. And clustering depends on remoting. Overwhelmingly, if you're building a distributed system, you should always use clustering. Clustering is the right tool for the job, and Akka.remote should be viewed as plumbing. That being said, there are cases where you'd want to use Akka.remote and standalone, and the best example I can think of is if you're designing imagine like a thick client, like a desktop application that has Akka.NET actors built into it that needs to communicate with some remote system. You don't want to necessarily have that desktop application be a part of your cluster. You might want to have it remote into it. We also have Akka.io now, which you could use instead. And we also have Cluster Client coming down the way too. So there's other tools for the job that are still being developed there. But if you really, the big difference between like Akka.io and Akka.remote is Akka.remote has location transparency built into it. Akka.io doesn't. Akka.io is kind of just like a raw socket connection that you can send data to. So one of the demos that Willie Ferguson, the contributor who ported it, wrote was you can use Telnet to talk to Akka.NET actors there. That's something you can do with Akka.io that you can't do with Akka.remote. Vice versa, with Akka.remote, you can have two remote actors talking to each other and have no idea that there's a socket there. So those are like the key differences between the two of them. Cool.
Awesome.
Great
Thanks
question, Alan.
So question actually that was for Joshua that came in a little bit after we switched. So Joshua, we have a question here from Simon Anderson. He's asking, how did you go about designing your overall actor architecture initially?
Oh, okay. So basically what we did was look at our building blocks. We had an actor and we had a router. And let's say we had a problem of stop time, so a vehicle stopping along a route. We took that problem and broke it down into, okay, as a stream of messages, I'm getting GPS in at the beginning. How do I turn that to a stop time, to something we can save and use later? So we looked at the problem. First, you need to figure out where the vehicle is on a route. So we have an actor for that. And then you need another actor that knows, okay, where are the stops on the route? And then it takes the messages, hey, a vehicle is here, and it's at this stop. And then it says, okay, so at this time, this vehicle is here. And then it passes it along to another actor that would save it into a database. So it's basically taking your problem and breaking it down into, okay, what are the little jobs that I can do that build up and solve this problem?
Yeah, that makes sense.
Yeah.
One of the approaches that we hear people talk about a lot is really starting to kind of cut up the hierarchy or chunk it underneath top-level actors that sort of represent an entire like domain of concern. Did you take any approach like that in your hierarchy?
We didn't really have the whole hierarchy tree or anything else. We just, sort of chained the actors together.
Got it.
Yeah.
Okay.
And marked up in terms of how we designed it. I actually drew an org chart for how we were going to organize our hierarchy, and I'd have something like this little portion of the org chart here. In fact, actually, I'm going to stop sharing my screen here. This little portion of the org chart here is going to be repeated for every single instance of this entity that we have. So if we have this app, and we have 1,000 of them that we're monitoring, we'll go ahead and have a little hierarchy like this for each one of them that would go and create. So that's how we did it, and we can link to the blog post that we published where I actually show what some of those hierarchies look like. So we'll send out a link for that as part of the YouTube Cliff Notes or something.
Yeah, we'll figure that out after.
We'll figure that out later.
So next question, and this is really for any of you guys that want to take it, is what's your opinion about? This is from Philip. I can't pronounce your last name, I apologize. But what is your opinion about another actor model .NET implementation, that being Microsoft Orleans?
I saw Roger unmute his microphone as soon as I came up.
Well, we were actually looking at both Orleans and Akka when we decided to overhaul our system. I could say at the time Orleans was not open source, so that was a big negative on there. Akka was open source, actively being developed. The community has grown larger and larger, and I would say there's a little plus on the Orleans side with the virtual actors, but we were able to do that in Akka, and with Akka you have more control over the infrastructure, like the consistent hashing routers and things like that. So that was definitely a big plus, where it wasn't just an abstraction over everything, and you weren't responsible for. Yeah, I don't know how to put the last part.
I guess the way I've heard it described is there's no magic. You basically understand what everything's explicit in Akka.net basically. Yeah. Roger, do you want to follow on?
Yeah, sure. I view Akka.net more like a toolkit, like Lego Techno, where you have very fine-grained building blocks where you can build anything you like, really, while Orleans is more prepackaged, where it's designed to run on Azure and it's designed to auto-scale. And even if they say it's the actor model, it's rather elastic objects. So you can have an object model that spans multiple servers. And Orleans is based on typed interfaces, which sort of contradicts some of the aspects of actors. So Orleans is more like elastic objects than the actual actor model. And you can take into account also that Microsoft is building Azure Service Fabric right now, and they decided not to use Orleans in that implementation. They rewrote a new actor implementation based on the same concepts as Orleans, but it's not the same implementation. So when Service Fabric comes out, I suppose Orleans will be deemed obsolete by that implementation. We are also working together with Microsoft right now to integrate Akka.net with the Service Fabric. So we have a cooperation on that. Whether they want to sort of leverage Akka.net's ability to run on devices and mono and pretty much anywhere, so they can make Service Fabric piggyback on Akka.net to reach out to devices.
Perfect. Perfect.
Last thing I'd chime in
go ahead.
there as part of that is a really big difference between Orleans and Akka.net is like in terms of what do you need to actually run an Orleans application. And with Akka.net, all you need is the CLR. With Orleans, you actually have to have their code gen tools built in, which inherently limit you from doing things like being able to run on Mono, for instance. And there's also, if you want to be able to use some of their distribution infrastructure, you need to have like a store set up, like Azure Blobs, Azure Table Store, or Zookeeper, any number of other providers built in to go and make it work. With Akka.net, we sort of have this like I guess Roger described it as like this Lego model, where you sort of go and add on the pieces that you need. So Akka.net scales down just as well as it scales up. You can have an actor system that's just part of like a desktop app or a phone application when we have support for those client profiles one day. Whereas with Orleans, it's designed to be sort of these big, heavy-duty sort of distributed systems from day one. So that's one.
So Aaron, you got a follow-up question. Sorry, you have a follow-up question from your presentation.
Mm-hmm.
From Max Yakamets. I hope I said your last name right. The question is, my app is a single source of truth, but then where is the persistence layer? What happens when one of the business logic actors gets disconnected and then reappears with stale data, and another instance has already taken over and moved the state?
That's a great question. So my answer to that is, so your application is the single source of truth. In our Akka.net design patterns course that we teach at Petabridge, the first thing we do is we have like this traditional n-tier diagram that has persistence at the very bottom, and it's like, okay, we're going to figure out how we do design in like a message-oriented system. And the first thing I do is I rip the persistence layer off the diagram, and you never see it again. And the reason is that persistence is a detail of how different parts of that system behave. It's not really like, it's more of a detail of a feature of your application, not like a core part of what it is. So unless you're writing like database software or something. So what I typically did, with our actors was, you can think of the marked up in-app marketing system as a big tree of finite state machines. And these state machines had to persist their state to Cassandra because I might accumulate 2 events on today that qualify a user for a campaign. I might get the 3rd event that I need 2 days later, and I might get the 4th event that I need 2 days after that. So I would need to have a way of being able to persist that state machine for millions of users over a course of maybe a couple of weeks potentially. And so the way we did that was, well, persistence is a detail of what these actors need to do in order to implement that feature. So we would go ahead and have them whenever they would, in my case, the way I wrote it was, whenever we had a dirty bit that got set in that state machine, it would flush its changes in its state to Cassandra. And it would do that before it would accept the next message. So it would go ahead and basically just operate that way. And so when one of those business logic actors would get killed, like for instance, whenever we did a deployment, we would kill hundreds of thousands of them potentially. They would go down all at once. The next time those actors would start up is they would go ahead and recover their state from disk. Now, there's a chance that some of the messages that were in flight whenever we would do that would have gotten lost. That's totally possible. In our particular case, with the way we designed the application, was it wasn't usually of any significance if that happened, because the events themselves were usually pretty frequent, and so we'd see another version of it again soon, usually. But if we really did care, then the way we would have gone and solved that would be on the other end of that service boundary, would have something like the at least once delivery actor and Akka persistence, basically get an acknowledgement back that message had been received by the appropriate actor before it stopped delivering it. And that would have actually been a pretty easy way to solve that problem. So there's a combination of like eventual consistency sort of going on here, just in terms of like when does that state get written, and where and a detail like where it is in your application. So the key part of that story that I have sort of just getting to now is that when we were making decisions about whether or not a user should be in a campaign or not, the state we were using to make that decision was always in the actor's memory. It was part of the actor's internal state. And it just treated Cassandra as like cold storage for in case it needed to be restarted or recreated later somewhere else. So that's the mental flip you need to make, is that The state of your application is something that's there, and it stays for as long as you need it. And that's what you use to make business decisions. You don't go and query the database to go and do that under these particular types of apps. The database is just backup, is what it is. That's what Akka.persistence is all about too. You aren't basically querying your durable store while your events are to make decisions. You go and get those events as soon as the persistent actor turns on, and it goes and recovers its snapshots and its journals. So that's a shift in the way we think about our relationship between our app and the database. So if that didn't make sense, ask a follow-up question below, and we'll cover that.
Right on. So next question from Yvonne Perez. Hey Yvonne, how you doing? Is asking, and I'll kick this one over to Roger or Joshua if you have any thoughts on the matter. Please chime in. Do you have any good examples of using Akka.net with the Saga pattern?
Well, you can sort of make sagas with actors really easily because they map very good to sagas. So in a saga, let's say you have two criteria that has to be fulfilled before you send another message to somewhere else. You can easily model that as you receive some sort of message, then you change your internal state of your actor, then you do nothing, and sometime later the next message comes in to your actor, and you check, do I already have the state for the previous message? If I do, I can then send the final message I want to send somewhere else. If I don't, I just set the state for my second message and wait for the first message. So sagas can really easily be modeled with actors. I don't have any good example for it, but it's easy to make.
Yep.
Aaron or Josh, any thoughts on that one?
Actually, I think kind of like how Bartosz has his really excellent CQRS example, we should probably do a Saga example too. That's a good one to put on the to-do list, actually.
Okay, right on. Okay, so next question, and this is one I will throw to Aaron and Roger, is from Alan Schrank. He's asking, now that version 104 is out,
Are we still on, or did it disconnect?
Hello?
I'm still here.
Aaron, you there?
Yep, I'm here. Looks like Google Hangouts had a hiccup there.
Okay, we had a little
all of
we had
us
a little blip there.
simultaneously. Yep.
Okay, are we all back now?
Yeah.
Yep.
Okay, so sorry about that, everybody. The question was, and I was directing this to Roger and Aaron, was from Alan Schrank. Now that version 1.04 is out, can you guys discuss the upcoming roadmap in terms of plans, features, and timeframes?
Yeah, I'd be happy to. So the next, we haven't publicly announced this yet, but I guess we'll just do it right now. Our target date for Akka.net 1.1 and is October 1st. That's what we've committed to in our contributor meeting. I guess about two weeks ago, maybe 4 weeks ago. We committed to doing Akka.net 1.1 on October 1st, and that is a stable release of Akka.cluster, is what that is. And that's goal of that is basically to have the Akka.cluster library no longer have the little beta tag on NuGet, and we're also going to release Akka.cluster.metrics as part of that too, which is the library you can use for doing load balancing across the cluster based on how busy the nodes are. So I can go and load balance to a node based on how much memory it has available or how the utilization on its CPU is, that sort of stuff. So that's the next immediate thing on the roadmap. We also have a sort of mini release that'll occur after that, where we might be able to introduce a TLS to Akka.remote after that. So that's something that's that I'm working on at the moment with a couple of other contributors. And then further out, further it's on a further time frame than that. I don't know, Roger. We haven't committed anything specific around 1.2 and 1.3 yet, have we?
No, not really. We are working on cluster tools and cluster sharding and
persistence.
Trying to, persistence, but nothing decided there yet.
Yeah. So the big priorities for the project right now is our high availability tools. So that's clustering, cluster sharding, cluster tools. At some points, that'll also include Akka streaming too. But they're still working on. They're almost done with it, I think, on the JVM side. But that's in terms of just the code footprint, that is a really large library. So we're sort of playing wait and see with that a little bit. Yeah, those are the big ones that we can share for now. That being said, we actually are doing like open. We actually have the sort of open participation model for contributors. So we have a bunch of new folks who just started working on clustering and remoting recently, and there's a lot more areas where we would totally welcome people's involvement. So if you're interested in working on Akka.net and being able to be a part of those releases, you can join our Gitter chat, and we'll put a link to that in the Hangout. But that's where all the magic happens, is in our Gitter chat. We've got something like 330 people in it now, so it's pretty big. But yeah, anything else you want to say on that, Roger?
No, not really.
Okay.
Okay, great. So let's move on. Joshua, this one's for you. Or at least I think it is, from Kudos Chaudhry. He says, when you say the application has its own state, do you mean Redis cache type stuff, or do the actors actually hold state themselves?
Yeah, I definitely can help answer this one. When you think of an actor, it actually does have state, so it's good to keep the state you need in your actor. You could keep it in Redis for like Aaron said, cold storage, but it's a little paradigm shift from just get everything you need out of the database. Your actor is live code. It's going to get its messages and everything else. So you can think of it as a cache itself.
Mm-hmm. Yeah, one of the real powerful realizations I had when I first started working on Akka.cluster about a year ago was I came up with a design on paper for how I could build a distributed cache using Akka.net, and I was like, man, this is actually like 1,000,000 times easier than I would have ever guessed. The idea of your application is the single source of truth basically means that the state literally resides in those actors. And you got to remember, like, actors are cheap. You can have millions of them running inside one application. It's something like a couple million actors per gig of RAM. Maybe it's a little bit higher than, a little bit lower than that now, since we've been adding some more features to what actors can do. But the bottom line with them is that they actually are stateful in and of themselves. And because actors, they sort of do one thing at a time, and because actors have private state, then you can basically have like really good state isolation between all the different actors that are running in your system. It's like one of the things that was really common between Josh's design for Synchromatics and mine for Marked Up was we used this tool built into Akka.net called a consistent hashing router to make sure that all the events for one entity. So in Joshua's case, an entity might be a bus. In my case, an entity might be a specific user using one of my customers' apps. We're able to go and make sure that all those messages always ended up at the exact same actor. So basically one actor would accumulate all the events for that entity regardless of where that event originated on the network. So that means that if I had 100 web servers and 30 of them all recorded one event that all belonged to one user, they could all direct those events to the exact same place in the network. And so this gives you the principle of what's called state locality, which is the idea of your application code and your data that the application depends on are adjacent to each other both in the way you've written your code, but also in memory. So you can react really quickly. You can achieve response speeds that are not possible with the traditional go to the database, get results, and do all that stuff. So I know that was definitely our experience. Josh, would you say that's true for you too?
Oh, absolutely. If we need something from the database, we load it up and keep it in the actor itself.
Yeah.
It's definitely in, and also as you said, the private state. So if you think about vehicle actors, they all excuse me, they all have their own location and where they're moving, and that private state becomes important there, to where we don't have to go to the database for that state. It's all in memory.
Yep.
Perfect. Okay, so we have two questions from the same person whose name I don't know how to pronounce. I apologize. First one is, any good examples on testing actors? I'll just answer that really quickly. Yes, there are some. We will share those in the show notes. We'll drop some links in there that you can look at. And also, I would suggest looking at look at the test for the framework itself. There's a lot of great examples there. And then I'll also tell you that we have a lot of we have some code samples and stuff that we're working up specifically on testing that we will be sharing on the blog. So that's that one. And then I'm going to throw this question from the same individual over to Roger. Roger, any guarantees about message ordering within an actor system?
Yeah, absolutely. There's strong guarantees for the message order. That's one of the principles of Akka. So it's guaranteed that if you send a stream of messages, they will arrive at the same order that you sent them. That's because actors have the notion of changing behavior based on a message. So if you can't guarantee the order of the messages, that guarantee wouldn't really work.
Yeah. We do have some tools within Akka.net that allow you to sort of mess with the message ordering to some extent. Like a good example is the priority mailbox.
Yeah.
Where you can basically imagine this is a mailbox with a priority queue built into it. So you can say this message is higher priority than this other ones who are in there. And then stashing is another thing you can do to kind of mess with the message order potentially. And that's sort of again.
I think we're back.
And
okay.
So hopefully Google gets an eye for infrastructure, the new Alphabet company. So
if you should throw in a U for user experience as well.
Yeah, an eye for infrastructure and U for user experience.
Okay, so sorry again, everybody. Hangouts decided to throw a little hissy fit, but we are back online now. Apologies. Okay, where the heck were we? We were talking about.
We got some questions from Igor.
Yes. Take it. Do you remember? I'm trying to load the questions again. We lost. Oh no, we got it back. So we have a couple questions from Igor. So first question is, do we have a Roger? Why don't you lead off on this one? Do we have a plugin API for third-party development? For example, if he wants to log actors' lifetime and messages.
Yes and no. We do support logging right now, where we can log actor life cycles. But for clustering, if you want to monitor your system, we don't really have a built-in support for doing that right now. Aaron has his own module for that, but you still have to write a little bit of code to monitor the actors. The guys on the JVM, they are currently designing Akka monitoring support. So they are looking at how to make those hooks right now. but that's not decided yet. So I guess we will follow their lead when they are done.
There's a lot of extensibility points within Akka.net where you can write your own little module and have it loaded in. So, for instance, you could go and write something like your own custom mailbox implementation, or your own custom network transport, or your own custom logger, and you have the ability to go and load those in using a couple of defined little configuration areas inside Hocon. So we do have support for that. And we also have the notion, and this is how I implemented like Akka monitoring, of an actor system extension, which is basically you can have like a singleton instance of an extension. So DI is in Akka.net is implemented this way right now, and so is actually technically clustering is implemented that way to some extent. So you do have, there's a couple of different points of extensibility within Akka.net today where you can do stuff. But as Roger pointed out, we don't have a wholesale like holistic approach to monitoring just yet. My approach for doing it is requires a bunch of application code to do that. So.
Right on. So, quick question from Igor also wants to know if you can use Akka.net with .NET 4.0.
I'm totally throwing you under the bus on that one, Roger.
Not right now. There's really no technical reasons why you couldn't do that, except for possibly the async await support. But technically, we could do support 4.0. But at the same time, 4.0 don't have the same task scheduler thread pool as 4.5 have. So the performance is a lot worse in the thread pool department. So even if we could support it, it wouldn't be as good.
Okay.
Yep.
All right. Next question is from Victor. Victor is asking, Akka.net has its implementation of finite state machines. What about workflows based on actors? Are there any plans to implement it inside the framework?
Well, that's really Akka streaming, isn't it?
Yeah.
Yeah. So Akka streaming is a way of basically imagine being able to express a workflow that's done using a certain family of messages and actors, and then being able to have that run like across a cluster over and over again, sort of like this repeated, like basically a repeatable workflow. That even could be, you can even have multiple copies of it running concurrently. Akka Streams is all about supporting that, and we don't have a port of that yet. That's something that's a little bit further down the road on our roadmap, and they're still even working on finishing that on the JVM side. But that's exactly what you're asking for, though.
Great. Okay, next question is from Anton. Anton asks, is there any part of reactive extensions used in Akka.net? Can I use RX streams that is observable in all the operators from an actor, or Akka.net, or does Akka.net completely replace RX functions so I don't need them?
That's a Josh question right there.
I would definitely say you don't need them. You could think of the actors and the way they handle messages as the reactive part. So, I mean, you can inside your actors use some of that, but really your actor itself is the little unit of work in that the RX.
You used RX and actors in combination together for a little while, didn't you?
Yeah, I was using RX to buffer up messages to save them to the database, and I basically removed the RX, had a list basically in the actor that I put messages in, and had a scheduler send a collect message. Yeah.
Yep.
All right. Okay, only other question I'm seeing right now. By the way, if anybody has other questions, please submit them. We would love to answer your questions. So other question I'm seeing right now is from Igor. He's asking, could you suggest a way to implement the cancellation of an actor's execution?
So Roger, do you want to take that one?
Sure. There seems to be some really strange background sound here. There, it's gone.
We're all muted now.
Yeah. when an actor is processing a message, you can't really cancel that specific message process for that individual message. What you can do is you can kill the actor itself if you need to, so it can't process any more messages. But when the actor is processing a message, you can't really do that. You can possibly do that with the async await support, because there you have tasks and you can send a cancellation token to the tasks and leverage the support for cancellation inside the task parallel library. But that's not really part of Akka itself. It's more like using that inside the actor. But the question doesn't really say in what way it means to cancel the execution, if it's killing the actor completely or just stopping one individual message processing. Aaron, do you have a better?
No, your answer summed it up for me. Like, the way I interpreted this question was, if you have an actor that's performing a long-running task upon receiving a message, how could you go and interrupt and cancel that work? And the way you described it was, put that work into a task and make it so the actor can go and just cancel that task some way, part of the way through.
Right on. Okay, so here's a really interesting question that we haven't talked about enough, I think. So I'm very glad that Simon Anderson asked this question. So Simon asks, if I have a crash log come in, I'll see a message in an actor, but I don't know where that message came from nor the states of other actors. Basically, Simon's asking, how do you debug?
How do you debug Akka.net?
What are your experiences been with debugging Akka.net? And I would expand on that and say, any suggestions, things to watch out for, etc.
Well, my personal experience with debugging Akka.net so far has been the one of the things that's challenging about Akka.net is that if you're dealing with a really high volume, and actually this is true of any high volume system, if you're dealing with a really big fire hose of messages that are coming through, getting a good stack trace for any individual one of them actually becomes a scalability problem, doesn't it? Like, if you have to go and, like I mentioned earlier, Marked Up was generating 500, handling it during peak hours 500 megs of event data per second. Well, if I had an actor that was failing in that, and I'd have to go and sift through, gigabytes of logs per day to go and do that, that could be a problem. So the way I solved that problem in really high throughput systems was through monitoring. I wanted to basically figure out how often my actors were crashing, and I designed Akka.monitoring, my plugin for that, to give you some metrics by which actor class is this thing crashing. So it can show you which actor implementations are having problems, and it'll also show you what's the path of this actor on the network too. So that's one thing. Is basically using monitoring as a way to figure out where you should even be looking. The second thing that I would say about debugging actors and such in production is one of the things that we're going to make a little bit easier, that will make it a little bit easier for distributed systems, is when we make the multi-node test kit a little bit more available and well polished than it is today. You'll have the ability to simulate things like what happens if these two services you built that use Akka.net can't talk to each other anymore. And you can actually do tests. And a lot of the things that are hard about doing network programming, like what happens when the network is slow or when it fails, or insert any other number of imperfect network scenarios, what happens? Being able to actually go and test that and see what occurs and what state your application is in and how tolerant it is to partitions is something that the multi-node test kit can help with. So I'm really looking forward to making that available as a way of helping test for those types of problems. And then otherwise, in terms of just general debugging, this answer is not the best in the world, but this is what I actually did. I would have 4 instances of Visual Studio running and basically have this system A over here send a message to system B, and I'd go and debug on both ends of the pipeline what was happening. And it's that's not ideal, but that's what I actually did to make that system work in production. So it's that's still There's probably some things we could be doing from a tooling perspective to make that easier. Roger just wrote a Roslyn code analyzer that can help detect common types of errors people introduce into Akka.net. So I'll give him the mic in a moment here so he can tell you a little bit more about that. But that's something that we're working on trying to improve in a number of ways with better tooling.
Josh and Roger, what do you guys think about debugging?
Yeah, in Akka.net we have pluggable support for different types of loggers, and one of the loggers we support is Serilog, and Serilog can send its logs into Elasticsearch. So if you use Elasticsearch and a tool like Kibana for visualizing your logs, that really helps with. There's a lot of background noise again. But Elasticsearch and Kibana really awesome for analyzing what's going on in your actor system, because you can sort of use widgets and graphs to show where different types of events come in from different systems. So that's really something I recommend. And I've also been talking to the guys on the JVM side in TypeSafe about making semantic logging the default logging approach in Akka and Akka.net. So they are looking into that also, because that will really help with the debugging of asynchronous systems. And also what Aaron talked a little bit about, the Roslyn code analysis stuff I've been looking into. There are some common pitfalls that people do when they write Akka.net code. For example, if you spin up tasks or some sort of asynchronous operation inside an actor, then you can lose some of the state that the actor has, like the current sender and the current message might not be there when the task completes if you don't use async await support. So I wrote a Roslyn code analyzer at any of those volatile properties inside any task continuation or task operation in your source code. This tool is mostly intended for the Akka.net source code itself, but I guess it could be used for end developer tools too. But that's intended to find the most common pitfalls where you might mess up concurrency inside the actors. Josh, do you have anything to?
Oh, absolutely. So here we use the Elk stack, so Elasticsearch, Logstash, and Kibana. We use that in combination with the Grafana and stuff. And I would say the key is unit test your actors. So when you do have an issue and you do start seeing stuff in Kibana, you can take those unit tests and get that actor in that state and reproduce the error. But a centralized logging system like the Elk stack is vital. Yeah.
Great answers. Thanks for taking that on, guys. So we actually had a bunch of new questions come in while we were answering that. So thank you everybody for submitting those. And Cecil, yeah, you're welcome. We're happy to do this, and we love having everybody here. So we're very happy to do it. Okay, so next question comes from Oleg. And Oleg's asking about Akka persistence again and application state. So his question is, what sort of strategy can we use for a financial application where we just can't lose state? For example, imagine a credit card processing center like Visa. Is the idea that the application is the single source of truth? Does that idea hold? And what if an actor fails before it saves its state? So I'm going to kick that one to Aaron first, and then round robin on from there.
Okie dokie. So my answer to that is, so the actor is the single source of truth in what the current accepted state of the system is. That being said, that doesn't mean the actor is the sole place where like the messages that you're sending are saved. So one of the things that we talk about like in the Akka clustering course that Petabridge does is this concept of what's called a service boundary. So you have, like, let's say you are Visa, and you have some piece of technology that represents like the gateway that the credit card terminals, when they're processing a transaction, write to. And that terminal might be implemented as a socket service, kind of like Josh's UDP data collector service for all those buses, or maybe it's a REST API, something like that. First thing I would do is I'd make sure that that service endpoint writes the messages that it wants to send to the actor system to a durable store and queues them up for redelivery in the event that the actor crashes before it has a chance to handle it. Exactly what you're talking about. So in Akka.net, the tool for the job for that is, it's part of Akka.persistence. It's called the at least once delivery actor. This is an actor that has ACK and NACK semantics built into it to make sure that the message was not only delivered, but that the actor who is receiving it also processed it. So that way it can say, okay, this credit card transaction has been committed to the state of our system, and we are okay. We don't need to worry about retransmitting it now. Other ways of doing that, like Josh, you guys still use RabbitMQ for doing that stuff, right?
That's correct. Yeah.
Because in your business, you have some metric you have to keep up, in terms of the accuracy of your data, right?
Yep.
Yeah. So why don't you talk about in production what that's like for you? Because you actually have a business case that's pretty close to this one.
Yeah. So right now we're using RabbitMQ from our gateway into the Akka system. I wish we had more than that. Once it gets into Akka, we're not using persistence yet or anything else. But yeah, like I could see RabbitMQ backed mailboxes and stuff like that, where yeah.
The idea is like you can basically define different points within your actor system using basic durable these at least once delivery actors that journal their state to some durable store and can retry to deliver messages. So that's how you do it. Is having the actor be the single source of truth doesn't mean that there aren't other places in your application that keep a record of that message needing to be processed somewhere. So if that didn't answer your question, I'll turn it over to Roger and see if he has anything to add or expand upon there.
Yeah, one system that I was involved in building last year was there we like Aaron said, we persisted all incoming messages on the endpoints directly when they came in, and then we had there's a lot of background noise again here. Let's say we had 5 services A, B, C, D, and E, and when messages came into service A, we directly saved the messages to a durable store, but then we didn't save anything when they passed through B, C, and D, and until we reached E again. And in service A, we place a timeout for like a day or so, that after a day had passed, service A asked service E if it had received the data it was supposed to receive, and if not, it could restart the entire process again. So you don't really need to have the safety net in each service, as long as you have all the data you need on the incoming endpoints. Yeah.
Awesome, cool. So we're going to go on to the next question, and so this one is from Philip, and Philip is asking about the relationship between the .NET project and the JVM project, and if I'm interpreting your question correctly, that is, Philip. And his question is, has JVM Akka ported any new features from Akka.net?
Started using Gitter after they saw that we were using it.
That's a community feature?
That's a community feature. So Roger and I meet with Roland, the JVM lead, once every couple of weeks, and we essentially our relationship with TypeSafe that's the company that makes Akka, is really good. They're good partners, and they've been super supportive of our project and answer a lot of our questions. And I know Bartosz, for instance, when porting Akka.persistence to .NET, found bugs in their implementation and reported it back. But so far, they have a roadmap that's based on, they've been in production for 4 or 5 years now, and JVM Akka is built into Apache Spark. It's used by Walmart and Twitter and LinkedIn. So they have a big backlog of issues that they're working on in order to serve those customers. We kind of have this green field, sort of open set of stuff that we're working on in .NET, and our ecosystem is fundamentally different in a lot of ways than the JVM. Good example is that dependency injection in .NET. .NET developers are addicted to this, to DI. We use it everywhere. In the JVM, you have like a handful of hardcore Spring people, and that's it. DI is a much less common thing over there. But that being said, we've floated some ideas over to them before, and I know, Roger, we've talked with them about trying to make the wire format compatible with Akka, JVM Akka one day, right? Yeah. What are your thoughts on that?
That was one of the initial thoughts that I had early on, but it soon became quite clear that it's hard to do interrupt communication between Akka.net and Akka, because if you send a message from Akka.net, you need to have the same message on the receiving side on the JVM, and maybe types don't match exactly. You need to implement the same class, sort of the same, and you would have to be compatible both on the transport layer and the serialization layer. So it's hard to get right, but we have talked with TypeSafe about it. And as I said earlier, TypeSafe is also looking at the semantic logging, which stemmed from our project. And I think they were looking at the plugin support we have for the one we use for stashing and dependency injection.
Oh yeah, the lifecycle thing.
Yeah. So there are some ideas they are looking at, but nothing final that they have said that they are going to implement.
Great, thank you. Okay, so quick question for Aaron is, what are the system requirements needed to run Akka.cluster?
How about it, Faith? Any
additions to that?
Any additions to that? Akka.cluster is, how do I put this? I personally haven't used it on Mono yet. I think, Roger, did you use Akka.cluster, the Raspberry Pi stuff, or was that just Akka.remote?
Yeah.
Okay.
No, I used cluster, and that works fine.
Okay, so it works fine on Mono and Windows. The one thing I would say, and actually this is true of any production deployment of Akka.net, is the machines you're deploying should have more than one core. So you don't want to deploy an Akka.net application on micro boxes that have like shared cores. And the reason is that Akka.net's designed to be highly concurrent, and it's going to do a lot of parallel message processing and that sort of thing. You're going to end up in a state if you have you're going to have a really jittery application if you run on one core. So you definitely want to. This is more for the cloud people than the on-premise ones. So basically, make sure you're running boxes that have at least 2 cores for every Akka.net application. That was something I found out the hard way at Marked Up. I was trying to see like how small my hardware footprint can be, and the Akka.net just had a really tough time on just a single core. But as soon as we introduced a couple of cores, then everything worked fine. In fact, we never really needed to scale beyond 2 cores for that per machine for that application. So that's one. And then the other thing you need to have for Akka.cluster is one of the things that's cool about it is Akka.cluster is elastic. You can go and add or remove nodes on the fly. But in order to add new nodes, you need to have what's called a set of seed nodes. And these are nodes whose IP addresses and ports are well known to the nodes trying to join the cluster. So like the way Josh deploys using something like Lighthouse is they have a couple of boxes that never get taken down for maintenance that have static IP addresses and ports that just don't change. That's one way of doing it. The other is, but if you don't do that, then the other way of doing it is, actually we have a sample using Azure Cloud Services that we'll be releasing soon. You need to use something like the AWS or Azure SDK to figure out what are the IP addresses and ports of other nodes you want to connect to. So you need to have someone who's some nodes need to be basically reachable by those new nodes trying to join the cluster. And then the final sort of system requirement for all this stuff is that if you're using Akka.remote, any IP address and port number that you need to bind to needs to be, you need to have make sure the firewall is open for that, and that the IP address is reachable by that socket. Domain names aren't something that sockets can bind to. Sockets can only listen on IP addresses. You can have a domain name resolved to an IP and make that work. And there's some stuff we actually cover in the Akka.remote docs that explains all that stuff, but that's something worth bearing in mind.
So I'm going to pick up a follow-on question from somebody else, from Cecil Phillip. Hi, Cecil. Asking about what are the plans for supporting Core CLR? Kick that one to Roger.
We have looked a little bit on that, but we decided to not do that in the core team because we are busy trying to port all the modules from the JVM. But I think we have a pull request somewhere lying around that makes Akka.NET run on portable class library and possibly Core CLR. I don't know. We have some user effort on that, at least.
Yeah. For the time being, we basically decided that Core CLR is a little bit too bleeding edge. I mean, it's in like Alpha 1 state right now, and we do want to support it when it becomes stable because we imagine that Dockerized Akka.NET applications are going to be pretty popular, and that's what the primary function of Core CLR is to have a reduced footprint for the .NET framework so you can Docker deploy it really easily. You don't want to have, on one machine, 12 copies of a 400 megabyte full .NET framework sitting around, right? So we will support it when it becomes more. I guess the right word is when it's more mature and when our users are ready to adopt it. Because, I mean, earlier on this call we had someone ask about .NET 4 support, right? So there's different. So users travel at different speeds in terms of how quickly they can adopt stuff. So the ideal for us would probably be like a PCL that could support both. But it'll be a little bit of time before we officially support it.
Great. Okay, next question is from Max. Max is asking, how good is the current implementation of Akka for replacing a while true loop in terms of throughput, context switches, and other CPU-heavy infrastructure overhead? Is it good for, say, example of a game loop, like processing, updating a game world, AI, and rendering in order?
I haven't personally done any game programming in a really long time, so I'm probably not the right guy to ask. But the overhead in the message passing pipeline locally is really, really slim. I don't think it's possible to make that any faster because on a single Raspberry Pi 2 machine, we're actually faster there than Project Orleans is on a 8-core server. So the message passing pipeline is really slimmed down. But if that is enough for an actual game, and depending on what type of game it is, I really can't answer that. But on a laptop, we can process between 30 and 50 million messages per second, I think, locally. So it's really fast, but I don't know how good that would be for a game.
For multiplayer games, so actually Jason Wyman, who just asked a question, I know he uses Akka.NET for like some Unity games and stuff that he's working on. We know like there's the Orbit actor framework that's based off Orleans in Java that got used to power Dragon Age 2. That actually powered like the game zones and all that stuff. It wasn't like Halo services where it just counted the number of headshots. This was actually part of the real core game engine itself. And that got used for basically being able to keep all the people in that multiplayer session synchronized. So I can't speak to like Roger said. I'm not qualified to comment on client-side programming for games, but for all the networked sort of multiplayer stuff, there's a pretty established history of using message-based architectures for that, and actors are one popular way of doing it.
Okay. Next question from Rodrigo. is any tips on how to expose some of the functionality of an actor system using Akka as a RESTful API?
Yeah, we do have that on the Akka.net site, on the documentation under the deployments, ASP.net. So there's examples there how to expose RESTful endpoints that talks to actor systems.
Great. Okay.
At some point in the not too distant future, we're probably going to have a combined like NancyFX plus Akka.net API out of the box, where you can literally have like a REST API that automatically maps down to each of your actors and that sort of thing. So that's kind of the equivalent of like Akka's HTTP library. But we haven't started. We don't have plans to implement that just yet.
So, question from Jason Wyman. Hey, Jason, who we were just talking about with the game programming. So Jason would like to know, and this is one for not directed to anybody in particular, but there's several supported logging options for Akka.net. Which one do you recommend? What are each of your favorites?
I would say Serilog, because it can talk to Elasticsearch.
Let's see. Currently, we use Log4net, and then we have a Logstash, basically a appender behind it to ship over to Elasticsearch.
I personally used Bartosz wrote an article about how to do this recently. I personally used a SignalR logger for debugging stuff, where I could go and watch my sort of logs coming by in real time, and that worked really well for me in production. That's what I used. So I had like a little debug page that get updated by SignalR on the fly.
Okay, so I guess, Jason, it's whichever one you like. Okay, so question from Natan. So Natan is asking, are there any plans for improving support? Any plans for improving support for methods that return tasks within actors, aka async await support within actors, including support directly in actor base? I'm going to go ahead and throw that one over to Roger.
Not for version 1. We talked about it for version 2, but nothing for version 1 because we're a direct port of JVM Akka and we can't really change the API that we committed to using. And the async await support doesn't really fit well with the design that was introduced in JVM.
Yeah, is this something that we might consider for typed actors one day in the future? I think we lost you there for a second, Roger.
Yeah, okay.
Yeah, one of the things I asked was, in terms of Natan's question, is this something that would be a good fit for typed actors, maybe?
Yeah, typed actors is a new feature they have just recently committed in JVM Akka, and you don't have the same problems that we see with the tasks and the current design of Akka.net and the design we inherited from JVM Akka, because all the state that you need to come back to in your continuations are passed into the receive methods, or rather the receive functions in typed Akka. So you have all the states that you need to use in your asynchronous flows.
Awesome. Well, guys, we are at the 2-hour mark, which is where we're going to call it for the day. So first of all, I want to thank everybody for being here, for the audience for participating. Your guys' questions were amazing. Aaron, Joshua, and Roger, thanks for fielding everything with having no idea what was coming your way and doing such a good job. So thanks, everybody, for being here at the first Akka.net meetup, and we're super excited to see you guys probably next month for the next one.
Thank you, guys.
All right, thanks, Josh and Roger and Andrew for putting us all together. This was great and really awesome to see all these questions coming in from the community. That was really great. All right, thanks, everybody.
Okay, bye, everybody.